Heat calculations, ice to steam. The example problem we have is taking 7 pounds of ice at negative 32 degrees Fahrenheit, and we're turning it into steam at 375 degrees Fahrenheit. So to set up this problem, we need to draw our scale. I'm going to draw this vertically. I'm going to draw a straight line up and down. And now I'm going to mark the bottom of my scale as our starting point. So we're starting at negative 32 degrees Fahrenheit. Our endpoint is the 375 degrees Fahrenheit. And we know we're dealing with water. So we need to know where the state changes occur. For water, using the imperial system here, we know that water freezes at 32 degrees Fahrenheit. We also need to know that water will boil at 212 degrees Fahrenheit. So anything below 32 degrees, we're going to be talking or dealing with ice. Anything between 32 degrees Fahrenheit and 212 degrees Fahrenheit, we're going to be talking about water. And anything above 212 degrees, we're going to be talking about steam. Each one of these will have a different specific heat capacity, so we have to do different calculations for these temperature changes. Starting at the bottom, I'm going to draw from my bottom of my scale. I'm going to draw a little triangle, and that's going to represent this range in temperatures. So I have 7 pounds of ice, and I need to warm it up from negative 32 degrees Fahrenheit to 32 degrees Fahrenheit. So 32 degrees Fahrenheit minus negative 32 degrees Fahrenheit is going to give me a temperature change of 64 degrees. I have to warm up this block of ice by 64 degrees. So I'm going to multiply that by 64 degrees Fahrenheit. Now I'm going to multiply this by the specific heat capacity for ice. The specific heat capacity for ice is 0.5 BTUs per pound per degree Fahrenheit. So what that means is it takes half a BTU to warm up 1 pound of ice by 1 degree Fahrenheit. When we look at this, that means that I have on my calculator, I'm going to enter 7 times 64 times 0.5. That gives me 224 BTUs. When we look at this equation, we have pounds, 7 pounds of ice per pound, so that cancels out. We have degrees Fahrenheit over degrees Fahrenheit. So the only unit that's left is BTUs, which is what we're looking for. How much energy is this going to take? And it tells us that it took 224 BTUs to raise the temperature of our ice to the melting point. We still have ice, but now it's 32 degrees Fahrenheit. So we have 7 pounds of ice. That hasn't changed. And now we want to melt this ice into water. So we have to look at the latent heat value for ice turning into water, and that's going to be 144 BTUs per pound. So for every pound of ice, it takes 144 BTUs. So we're going to do this multiplication of 7 times 144. And that gives us the energy of 1,008 BTUs to melt this block of ice into water. So 1,008 BTUs took my 7 pounds of ice at 32 degrees Fahrenheit and melted it into water at 32 degrees Fahrenheit. So now I have water, and I need to raise the temperature of this water. So again, I'm going to draw this triangle here. And I have 7 pounds of water. That hasn't changed. And my temperature change in this case is going to be 212 minus 32, which gives us 180 degrees Fahrenheit of temperature change. Now, the specific heat capacity for water is going to be 1 BTU per pound per degree Fahrenheit. So again, to raise the temperature of 1 pound of water by 1 degree Fahrenheit, it now costs us 1 BTU of energy. So our units are going to cancel out here. My pounds and pounds are going to cancel out. The Fahrenheit is going to cancel out, and we're left with units of BTU. We crunch out this number. We have 7 times 180 times 1, and that's going to give us 1,260 BTUs to warm up our water to the boiling point. So this 1,260 BTUs heated up our water from 32 degrees Fahrenheit to water at 212 degrees Fahrenheit. So now I have 7 pounds of water that's ready to boil. And now we have to look at the latent heat value, which is going to be 970 BTUs per pound. Again, there's no temperature change here. So I have 7 pounds of water, and it costs me 970 BTUs per pound. So I can do this multiplication of 7 times 970, and that means it took 6,790 BTUs to turn all our water into steam. So now I have steam at 212 degrees. So again, I'm going to draw my triangles here. And I have 7 pounds of steam. And I want to raise the temperature of my steam from 212 to 375. So 375 minus 212 is going to give me a temperature change of 163 degrees Fahrenheit. I now need the specific heat capacity for steam, which also happens to be 0.5 BTUs per pound degree Fahrenheit. So again, this means it takes half a BTU to warm up 1 pound of steam by 1 degree Fahrenheit. So these units of pound and Fahrenheit are going to cancel out, and I can crunch these numbers. So I take 7 times 163 times 0.5, and that gives me 570.5 BTUs to warm up my steam from 212 degrees Fahrenheit to 375. So what the question is usually going to be asking us is, what is the total energy? So now I need to add up all these energies, and that will tell me how much energy it took to melt this block of ice and turn it into steam at 375 degrees. So on my calculator, I'm going to take my 224 plus 1,008 plus 12,060 plus 6,790 plus 570.5, and that's going to give me a total of 9,852.5 BTUs. This type of question may or may not include state changes. Sometimes these questions will simply be calculating the energy for a difference in temperature. Sometimes we'll simply be melting a block of ice. So you'll have to look at the range of temperatures and see if you're doing a state change or not. In this case here, we had 5 calculations to do. We had our sensible heat calculation, which is us warming up the ice here. Then we had our latent heat calculation, which was just a state change. There's no temperature change here, this flat line, but we did change the state. We changed from ice into water. So that is a latent calculation. Then we had water at 32 degrees, and we heated that up to 212. And that is a sensible heat calculation. We've raised the temperature of the water. The next calculation we had to do was at this flat line at 212, as we had water at 212 and we needed to change it into steam. We had a state change. So the temperature doesn't change, but the state of our material does. Once we changed the water into steam, we had steam at 212 and we had to raise the temperature of that steam to 375. So we had a temperature change or a sensible heat calculation.